All right, so here we are back at the drawing board. Fortunately, we don't have to start from square one. I'm just going to take the version 1 of the cone, which you can see here, and do all of the modifications from there. That way I don't have to do everything from scratch over again. And, since version 1 was a failure anyway, it's not like I need to save that cone. So, excuse me. So right in here now, I'm actually resizing the cone itself to the parameters that I wanted to change them to, and I know I'd said that I was going to keep the cylinder itself the same size, but after looking at it, the reduction at even at the wide end of the cone, the cylinder would just be way too big, much larger than necessary. So, after I resized the cone itself, I think I am going to slender down that cylinder a bit and make it a little more proportionately in line, because why not? When it comes to printing it, it'll be using less plastic and whatnot, so environmentally responsible and whatnot. Yeah, of course, you saw here just a few seconds ago that I ran into the same problem that I had the first time, and that being the top of the cone, we don't get real measurements for. We only get that numeric value that I wasn't able to quantify to any actual distance. Now, whether or not it is an actual distance or not, I just don't know. Because like you can see here, everything on the actual grid has a legitimate physical dimension that I have it split down to 64ths of an inch. But with that numeric value over in the column for the top radius, I don't know what that correlates to. So unfortunately, I'm kind of winging and praying it. But anyway, I think I've got it all. I did everything I said I was going to do, narrowed in both of the ends of the cone, brought down the cylinder, made the cylinder a 1/4 inch shorter. So I will save this puppy as version 2, and we'll get Kira booted here and get it all sliced up so I can get it into the 3D printer. Fortunately, this whole process, has kind of been simplified because it has all of the settings from the previous one, so I just need to make the proper adjustments. So here, I don't even have to mess with it at all. I know exactly what it's going to do because it's just kind of a smaller version of the one that it already printed. As I said, I changed the infill density down to 10%. Do a check and make sure everything's all right. Looks good. So we'll save this one and bring that file over to the 3D printer and see if we can get it in 2. Okay, I did take pictures of Cone 2.0, but it basically looked exactly the same as the first one. It's just a little bit smaller. The one thing that of note, as you can see here, is the difference between the 20% infill that I had in Cone 1 and the 10% infill that is in Cone 2. This is the 20%. You can see that it's a much tighter grid work than cone number 2 at 10%. So that was the only real difference, so I'm not going to go into a lengthy explanation. I didn't have any issues printing cone number 2, so yeah, it finished up nice, and now we'll go to the video and see if it actually is what I need it to be.
All right, cone test 2.0 has finished. Actually looking at it physically, it's a lot closer to what I'm actually looking for. So, I mean, you can compare it to the old one. I mean, like, I don't know why. I mean, I don't know. I think I might have messed something up when I was in Tinkercad or something. But yeah, that's way, way bigger than it needed to be. So we're looking at this. I mean, and you can see the difference here. I mean, it's crazy. So let's see if I got it in 2. And I don't think so. I'm close, but I think I closed the hole at the bottom too much, and so I'm not getting it. I mean, it's nowhere near. So, yeah, I think I made the hole too small for this one. So I'm going to widen it out. I'm probably going to a little bit more than double it. And hopefully that gives us what we need. And yeah, and then let's hope that the third time's a charm. Back to the drawing board again.
All right, let's do this hopefully one more time, and that's it. I obviously did not fully factor in the entirety of the slant of the cone when I redid the smaller end of the cone for version 2. And so somewhere in there it got stuck because the cone overall just wasn't wide enough. So I think I'm going to approximately double, maybe 2.5 times it. And so now I'm, running into the problem that I ran into before with the not knowing exactly what distances are for that, what Tinkercad is calling the top radius. So I guess I'm just gonna have to guess and see if it works out. Not my preferred way of doing things, but I don't know, maybe I'll research it and see if there is method to that particular madness. And if so, I will be sure to mention it the next time I use Tinkercad, because I'm sure it's going to happen. In general, I really like this program. So anyway, so I'm basing it visually, and it looks like that's what I'm going for, somewhere between 2 and 2.5 times larger than the hole was for version 2. So that's the only thing I needed to change. So we'll save that as the old STL, and we'll name this one version 3. And send it on down to Kira. And God, I'm really hoping this one works. But I mean, that's part of iterative design. You have a good idea, so you build one, and when that doesn't work, you tweak it until it does, and sometimes that can take quite a few times. I mean, honestly, so far, the projects that I've done, and I know I haven't done a ton of projects for TTGS yet, but in general, my luck's been pretty good in terms of the amount of iterations to revamp things. And I say that even keeping the honey soda project in mind, and I don't even remember how many times I had to alter that, but that was still pretty good, all things considered. So you can't be afraid to change and tweak, even if it happens a billion times. So otherwise I'm keeping everything the exact same, so I don't have to change anything in Kira. So we'll save it, and we'll send it over to the 3D printer. Probably won't be any pictures of this one because it's going to be almost exactly the same as the last two, so you're not missing anything. And that'll be it. Wish us luck.
So here is code test 3.0. Compared to version 2, you can see, like I said, I a little bit over doubled the size of the hole, and it should still be smaller. Yeah, it's just a little bit smaller, not a ton, but a little bit smaller than the original. So, for all intents and purposes, this should work. So, let's see. Okay, so it goes down right to where I want it, which is just shy of where the leaf part of the bouquet is. So that way, when it's in the planter, I can spread those leaves out and give it a little more of a in a planter look. And then you can see here it's just poking out the bottom. Now it's a little big, but that's okay, because the idea is that it's a catch, right? So we know, and I'm putting quite a bit of pressure on there. It is not going past where I want it to be. So I think we can call this good, because I can put the glue or epoxy, or I still haven't decided what I'm going to use to stick this thing together yet, but we still got a ways to go, so I'm not too worried about it yet. Yeah, no, that's the size. Like I said, I cut it down that 1/4 of an inch, so it's not quite as tall. And I think between that and narrowing in the top considerably, and then widening out the little bit from how super thin it was on the version 2, I think that's gonna do it, at least for the cone. I don't know about how large the outer cylinder is going to be, but that will be more of a design issue when I come up to actually building the entire cap for the planter. So like this will go somewhere inside. I haven't decided where it's going to be yet, because I don't know how big it's going to be the right proportions. But then, so it'll sit in this floating, and then I'll have like a false bottom. And yeah, so anyway, so those were the two working parts I needed to test. So now we know that it will fit the can, and we know that it will properly house the bouquet the way I want it to. So from here, we move on to the design of the actual full thing. So here we go.